Hello guys, in this video I'm gonna show you how to calculate the integral from 0 to 1 of x to the x dx. So x to the x is equal to exponential of x ln x. So we're gonna have the integral from 0 to 1 exponential of x ln x dx. And we know that the exponential of x by the Taylor series is equal to e to the x equal to sum from 0 to infinity of x to k x to the k over k factorial. So that would equal to the integral from 0 1 the sum from 0 to infinity of x ln x to the k over k factorial dx. We're gonna bring 1 over k factorial to the front, and we're gonna exchange the sum and the integral. That's gonna give us the sum from 0 to infinity 1 over k factorial, the integral from 0 to 1 of x ln x to the power of k dx. So now we're gonna calculate the integral from 0 to 1 of x ln x to the power of k dx. We will make a substitution. We're gonna say that minus u equal ln x. That will give us that minus du equal to 1 over x dx. And we know that x is equal to the exponential of minus u, so dx equal minus d to the minus u dx du. So we're gonna put that in our integral. It's gonna give us the integral from 0 to I actually did a mistake here. It's the integral from infinity to 0. I will correct that here. So it's the integral of the exponential of minus u multiplied by minus u to the k multiplied by minus u to the minus e to the minus u du. We're gonna exchange the borns of the integral. It's gonna give us the integral from 0 to infinity of the same thing, the integral of minus u k plus 1. So that's very obvious. Minus 1 to the k of and multiplied by u to the k du. I will make another substitution. Let's see. I will rewrite the same integral. It's the integral from 0 to 1 x ln x to the k. That would give us minus k from 0 to infinity of minus u k plus 1 multiplied by u to the k du. And I'm gonna make another substitution. I'm gonna say that t equal to minus u u k plus 1, so that dt equal to du multiplied by k plus 1, so that dt du will equal to dt over k plus 1. I will put that in our integral. It's gonna give us that minus 1 to the k, the integral from 0 to infinity of e to the minus t multiplied by t over k plus 1 to the k dt dt over k plus 1. And that's equal to minus 1 to the k, the integral from 0 to infinity of e to the minus t to the power of k multiplied by 1 over k plus 1 to the k plus 1 dt. I will bring 1 over k plus 1 to the front, and if you know the gamma function, that's very obvious. The gamma function of z equal to e to the minus t, or gamma of x equal the integral from 0 to infinity of t to the x e to the minus t dt. That's the x minus 1 factorial. Here we have the gamma of z equal the integral from 0 to infinity of e to the minus t to the z minus 1 dt. And what we have here, the integral from 0 to infinity of e to the minus t to the power of k dt, is gamma of k plus 1, and that is k factorial. So the gamma function is expansion of the factorial, so that will give us gamma of k plus 1, and gamma of k plus 1 is k factorial. So that will give us minus 1 to the k over k plus 1 to the k plus 1 k factorial. So our first integral, the integral from 0 to 1 x to the x, is actually equal to the sum from 0 to infinity of 1 over k factorial multiplied by minus 1 to the k over k plus 1 to the k plus 1 multiplied by k factorial. We're gonna get rid of the k factorial. Is gonna give us the sum from 0 to infinity of minus 1 to the k over k plus 1 to the k to the power of k plus 1. And we're gonna make another change of variables. It's gonna give us the sum from 1 to infinity of minus 1 to the k to minus 1 to the power of k minus 1 over k to the k, and that's 1 over 1 to the power of 1 minus 1 over 2 to the power of 2 plus 1 over 3 to the power of 3 minus 1 to the 4, and so on to the infinity. That's the integral of x to the x. And guys, don't forget to subscribe and leave a like, and thank you for watching.